So what we're doing here is we're actually going to solve these equations, and we're using everything that we've learned from this whole chapter in this section. All right, we need to know what our 30, 60, 90, 45 values are. We need to know how to factor. We need to know how to manipulate our trig functions and all of our identities so that we get it in the right format so that we can solve. So we need to talk a little bit about some terminology. Principal values. Principal values you restrict your usage into two quadrants. One quadrant where it's positive and one where it's negative. One quad for positive values and one quad for negative values. We use the sine and tangent. They use the same quadrants when we deal with principal values. We agree that they're all positive in the first quadrant, and they're going to be negative, both negative in the fourth quadrant. So we look for our values that fall between, and we say that our domain falls between negative 90 and positive 90. So when I'm talking about principal values, the solutions that I get, my answers fall between negative 90 and positive 90. In other words, don't tell me it's 270, because 270 doesn't fall into that domain. Does that make sense? Even though negative 90 is the same thing as 270 degrees, we want our answer to fall between negative 90 and positive 90. Okay? So we're using these two quadrants. Cosine's domain is positive here and negative here, and so its domain, its answers are allowed to fall between 0 and 180 degrees. So we're using these two quadrants. That's only when you see the word principal values. If I don't see the word principal values, then what you will see is you will see a domain given to you, generally from 0 to 360 or from 0 to 2 pi. All right, so solve for principal values. This is just a really simple, 3 simple problems. If I tell you that the sine of x is equal to 1/2, and I want the principal values, then the only quadrant where I can find a sign that's positive is in which quadrant? Okay, so my answer has to be in quadrant 1. Because it says principal. And principal lets me use only one quadrant for positive and one for negative. Okay? All right, so the sign of what is 1/2? Therefore, x is 30 degrees. It falls within my domain. Okay? All right, the next one says sine x squared, or sine squared of x equals 1/2. All right, so let's go back and let's kind of review a basic algebra problem. If I gave you x squared is equal to 1/2, what would you do to this problem to solve for x? And if I square root both sides and I'm dealing with an equation, then my value for x is what? Positive and negative square roots of 2 over 2 when we rationalize that, right? Remember, in a square root, if it's given to you in equation form, when you take the square root, you get a plus and minus. So the same format is used here. I need to get to sine. I can't have sine squared. So we take the square root of both sides, and the sine of x is equal to plus and minus square roots of 2 over 2. Okay, so now I'm wanting the quadrant where it's positive and the quadrant where my answer is negative. And if I'm dealing with the sign, then which quadrant am I going to be using? First for positive, and which one for negative? Fourth for negative. Well, the sign of what? What is our reference angle if I'm dealing with square roots of 2 over 2? 45. So in the first quadrant, wouldn't you agree that my answer would be 45 degrees? Now remember what my domain is. My answers have to fall between negative 90 and positive 90. So we're going to put a 45 degree in the fourth quadrant for it to be negative, right? And we're just going to say that it's negative 45 degrees, right? Don't say 315, even though we end up in the same place. We've gone around in a positive direction, and we want it to go in a negative. Okay, so the cosine squared of x equals 1/2. What are we going to do? Square root it. So that means the cosine of x is equal to plus and minus root 2 over 2 when I've rationalized it. Well, which quadrant is my cosine positive in? Positive in the first, and negative? in the second. All right, this is a thought process that you have to go through as you're doing these. So we know that it's still going to be a 45-degree angle, correct? So put that 45 angle in a first quadrant and in the second. So in quadrant 1, it's going to be 45 degrees, agreed? And in quadrant 2, what is my angle? 135 degrees. Because my answer has to fall between negative 90 and positive 90. So I don't want to say 315 because that's outside that range, right? I got to say that I'm going down negative 45. Okay. So the rest of the note should be pretty much the same, I think. If you go back to the first page, is this what y'all have? Okay, so you've got to think about this in terms of algebra. If I were to make this just a general algebra statement, what would you write? Like, get rid of my signs and my sign squared, and I just put in variables. What would this say? Right. So you got to remember, what is this really saying? It's just a basic algebra problem. And if I'm asking you to solve, and I give you this as a polynomial, you would tell me to do what? I would factor. So you've got to use your algebra skills, okay? So this would factor to 2x and x. If I want a plus, this has to be positive, and this is going to be negative. And now let's replace our x with what? So 2 sine of x minus 1 and sine of x plus 1 equals 0. So if I'm going to go through my solving process, now remember, I'm still in principal values. Okay? I'm still in principal values. What am I going to do now to solve? Okay? 2 sine of x minus 1 equals 0, which means the sine of x is equal to 1/2. And here the sine of x equals negative 1. Which quadrant am I going to use for a positive answer? Which quadrant will I use for a negative answer? The sine of what is 1/2? That's a quadrant 1, right? See why you need to know these values? You can't be struggling not only to solve, but also what are those values? Okay? The sine of what is negative 1? Negative 90. So you can think in your head that's 270, right? But 270 falls outside of my range. I have to think about my range between positive and negative 90. So we're going to say that that's negative 90 degrees. So negative 90 and 30 degrees are the two values that make this equation true. I did. I found the negative here. Why? Did I take a square root? Right? Wouldn't this 2x minus 1 equals 0 gives you 1/2, right, for x? Not a plus and minus 1/2. All right. So look at this next equation that I give you. If I ask you to solve, mathematically, what did you learn? What have you learned how to do? Because you have to set it equal to 0 in order to solve. So therefore, this would give me 2x squared minus x, and my 1's are going to drop out, equals 0. And then if I continue to ask you to solve, what would your next step be? Pull out an x. And that leaves me with 2x minus 1, which tells me that x is equal to 0 and 2x minus 1 equals 0. So you have the tools to do these problems. You just have to be able to translate these into these trig equations, okay? So look at this problem here. Now, how do I know that this is in principal values? This statement right here tells me I am allowed to use all 4 quadrants. Now, the other thing, how do I want my answer written? It's got to be written in radians. If I wanted it in degrees, what would my domain have said? 0 to 360. So be very careful. However my domain states is how I want my answer to be written. So this has to be written in radians. Okay? Okay, the next problem that I have is what? Okay, I can move the cosine squared over. Sine squared of x minus sine of x plus 1 minus the cosine squared of x equals 0. Does this make this any easier to work with? If I'm going to chunk or group, I've got to have something common that I can pull out of each of my terms, right? I like that. Sure is. So she's saying the plus 1 and the minus cosine squared is the same thing as sine squared. Would you agree? Right? So you've got to remember your identity. Sine squared plus cosine squared equals 1. If I'm going to subtract the cosine to the other side, then I have a 1 minus sine, or 1 minus cosine squared, correct? So we're going to do a substitution, and so now what we have is 2 sine squared of x minus sine of x is equal to 0. So you can't really solve this unless you can either pull something common out of all of the terms to eliminate that extra trig function, or do a conversion so that they're all in the same trig formation of either cosines or sines. Okay? What am I going to do now? Pull out a sine. That leaves me with 2 sine of x minus 1 equals 0. So therefore, the sine of x is equal to 0, and 2 sine of x is equal to 1, or the sine of x is equal to 1/2. Okay, I'm allowed to use the entire unit circle because that's what my domain says. So where does the sine equal 0? At 0 and? But I need my answer in radians. So I'm going to say 0 and pi. Because technically we shouldn't really have that equal sign, because if I start at 0, I don't want to repeat myself at 2 pi. Does that make sense? I need to stop and not include 2 pi. So I shouldn't have had that equal sign there. 0 and pi. And the sign of what is 1/2? So it's a pi over 6. And we're going to put it in which quadrants? If I'm allowed to use all my quadrants now, because I don't have the principal value statement, then I'm going to put pi over 6 here. And where else is all students take calculus? Where else is sign positive? So I'm putting a pi over 6 in each quadrant. Wouldn't you agree? So that means pi over 6 for a first quadrant. And if this is 6/6, what is a pi over 6 in the second quadrant? 5 pi over 6. You see how we're using everything we've learned? All students take calculus. The sign is positive here and here. I need to put a 30 degree in the first quadrant. That's pi over 6. If I'm going to put a 30 degree in the second quadrant, and I'm using 6, this is 6/6, so I'm going to go up 1/6, which gives me 5/6. If I needed to go down, this would have been 7/6, right? Over here, I would have had 11/6. You following this? All right, here we go. Yes. It's all 4 of those. Okay, here we go. What am I going to do on this one? Why not? Well, if I group, right, 4 terms, grouping is an option. Let's look. We've got to make them look the same. What can I pull out of the first 2? And that leaves me with, and can I get 2x minus 1 over here? What would I pull out? Oh, this should have been, let's make that positive so it works. Okay, my point was, yes, you need to remember that grouping can work. Okay, Helene, this wouldn't have worked the way it is because if I pulled out a 2 or a positive, a negative, that would have changed this to positive, and then my parentheses wouldn't have been the same.
Oh, why is my parentheses? I excluded the negative.
You can't. You can't. Okay, so we're going to group here. And notice, how do I want my answers now? In degrees. And again, I don't need that equal sign. It should be just strictly less than 360. Otherwise, I'm repeating myself, right? So what would you group out of each of these? 2 sine of x for the first one leaves me with a 2 cosine of x minus 1. Remember, every place has to have a value. What am I going to pull out of the next two? Just a negative root 3. That leaves me with 2 cosine of x minus 1. Okay, so then how am I going to finish this off? Times 2 cosine of x minus, therefore, 2 sine of x equals root 3, or the sine of x equals root 3 over 2. And this one tells me that the cosine of x is going to equal 1/2. I'm using the entire unit circle. Therefore, sine is positive here and here. The sine of what is square roots of 3 over 2? 60 degrees. So I'm putting a 60 degree in each quadrant, which tells me I have 60 degrees and 120 degrees. That's for this problem. Are we comfortable with this? Okay, I need cosine. Where is cosine positive? First and fourth. Okay, cosine of what is 1/2? So I need a 60 in the first and the fourth. So that's 60 and 300. All right, so we're combining our answers. We don't repeat an answer. We don't write 60 twice, do we? So x is going to equal 60, 120, and 300. Are we getting this? Because I got 60 and 120 from this one, and I got 60 and 300. So the answers is a combination of both of those. Okay. All right, solve for x in degrees. 2 sine of x plus 1. So you do this one. Yeah. If I don't see the word principal, you're going to want to assume. And let's do this one. 0 less than equal to x less than 2 pi. Let's make that in terms of. Yep. Let's make this one instead of degrees. Oh, because I said this, but let's make this in radians. Just because I want you to think. So which quadrant am I working in? Third and fourth. Because all students means it's positive here and positive here, but I'm looking for negative 1/2. So I have to be in quadrants 3 and 4. So what's my reference angle? So it's a 30 degree, right? So we're going to put a pi over 6 in here and a pi over 6 in here. That means this is going to be what? 7 pi over 6, because this is 6, 6. Then this is 12, 6. So what is it in here? 11 pi over 6, right? Oh, bless you. Okay. Okay. You try this one. So you've got to keep track. Do I want positive or negative values? And then which quadrants give me the positive and which ones give me the negatives? So before you get too far, what's the tangent of x equal? You're half right and half wrong. Plus and minus root 3 over 3 because you're taking the square root and you're getting a plus and a minus. You're going to use every single quadrant. And the tangent of what? It's positive here and here, negative here and here. So you are right. We're using all 4 quadrants. Yes, ma'am. Because when I take the square root of 1/3, I have to rationalize it. Yes, these are your negative values, and these ones are your positive values. Okay, try the next one. And this one, notice what this says. This says for all real values of x. So that means for any amount of rotation. So let's just think about what we're going to get. Okay, let's just solve for it normally. First thing I need to do is what? Bring the 2 over. I can't solve unless it's set equal to 0. That's what we learned in algebra. I can't see what to do. Set it up like an algebra problem. What should I do? Okay. So that tells me that the cosine of x equals -2 and the cosine of x is equal to? Okay. What happens here? Well, cosine of what is -2? Nothing. It's an extraneous answer. Your answers are going to fall between positive and -1 for cosine. You're never going to get a -2. So sometimes these answers aren't going to work. Remember, extraneous solutions? We had them in algebra. Cosine of what is -1? 180 or pi. Okay, so we want to be able to go around an undetermined amount of times. And so when I say for all values of x, I'm going to say pi plus 2k pi. Well, because it says all real values. This k is equal to your revolutions or your rotations. So if I always want to end up at pi, then I'm always going to add 2 pi to that value, right? So I can go around once, or twice, or 3 times. Does that make sense? Okay. All right, I got to do some more. I'm going to do this one. Here is my issue. Sine of 2x. This is a problem because in all of the other problems, what was our variable? 1x. And now I have 2x. So when my thing is 1x, I was always falling between 0 and 360. But now my answers are going to fall between 0 and 720 twice. Okay? So because of the 2x, we are looking at values between 0 and 720. Because we're doing 2 rotations. Okay? So we're going to look at this as, we're going to say the sine of what? Let's just look at this as y. The sine of what is 1/2? 30. And so we're going to put it here and here, yes? And so we're going to say y is equal to 30, and y is going to equal 150 degrees, right? Does that make sense? And so we're going to go around again. And so we're going to add 360 to get our second one, which gives me 390. And then we're going to add 360 again to my other answer, correct? Because remember, my answers are going to fall between 0 and 720. And now that's going to give me 510. So 2x is equal to 30. 2x is equal to 150. 2x is equal to 390. And 2x is equal to 510. Okay? However, our final answers always have to be within 1 rotation. So what am I going to do? Divide all of my answers by 2. Therefore, I'm going to have a 15 degree, a 75 degree, a 195 degree, and a 255. So my final answer always has to fall within 1 rotation, even though we're doing 2 rotations in the problem. Okay? If I did principal values, I'd be stuck only with the 30, wouldn't I? So that would give me 30 and then 390.
Oh, when you say negative 30?
No, because it's positive. I'd want the quadrant where it was positive. The negative 30 would be in quadrant 4. But remember, if it was principal values, I could have one quadrant where it's positive. That would be the first quadrant. Second quadrant is where it's negative. I can only do. So I don't want to use the fourth quadrant. If I was doing principal values, my answer has to be positive. I'd be using just the first quadrant. I wouldn't use any other quadrants.